is way too hot. Venus is horrendously hot, and 90 atmospheres pressure and sulfuric acid rain, it melts lead on the surface, right? So you're not going there. And the rest of them are made of gas, so you're not going there either. So Mars is the only place beyond Earth that we could feasibly ever go planet.
So Brian, we're doing this episode of Minutes With very different from anything we've done before. We've put a survey out to the audience, asked them to send in all the questions they want to ask you. What is the one fact about the universe that blows your mind the most?
There are a lot of things about the universe that I find it almost impossible to imagine. Well, actually impossible to imagine. One is just the size and scale of it. I mean, in the piece of the universe we can see, there are something like, roughly, 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy. And there are 2 trillion of them in the piece of the universe we can see. And we're very sure that that piece that we can see is a small bit of what may be an infinite universe beyond. We don't know, actually. And I always say, don't get worried about that, because nobody can picture it. It is impossible to visualize the scale of the universe. So that's the first thing. I could then list a lot of more things, but we'll stop there for now. But just the size and scale of it, I think, is beyond imagination.
There's been a lot of references to the multiverse and parallel universe in popular culture lately. Do you think that something like this is a possibility?
So there are lots of multiverses, actually, in physics. One of them is called the inflationary multiverse, which is we have a theory of essentially what happened before the Big Bang. Right? You have to be careful with the language. So if you define the Big Bang really carefully as the time when the universe was very hot and very dense, and as I said, you can't argue with that because we can see it, because we can look out into the sky. Our best theory of how the universe got into that state is that there was a time before that, and it's called inflation. So the idea is the universe was there, in a sense, cold and empty and expanding extremely fast. And that expansion slowed down and stopped. And the energy that was driving that expansion got dumped into space, heated it up, and made all the particles out of which we're made. And that's what we call the Big Bang. So that's textbook. It's a textbook theory called inflation. It made predictions, some of which have been tested. Some incredible predictions, actually, about the way that galaxies are distributed across the sky, because they're not just random. If you look at the galaxies, they're in sort of flows and rivers of galaxies that cross the sky in a pattern called the cosmic web. And inflation predicted that before it was seen, actually. So it's an astonishing idea. And that theory has a kind of an extension called eternal inflation, which is that the inflation essentially goes on forever. And it just stops in little patches. So you imagine the fabric of the universe, space-time, stretch. And then it slows down and stops in little patches. And each one of those patches is basically a Big Bang and a universe, of which ours is one. So you end up with this sort of picture of an infinite fractal universe of basically an infinite number of Big Bangs. And that's called the inflationary multiverse. And it answers some neat questions, because if you say, why is our universe the way that it is? Why are the laws of nature such that life can exist, for example? Well, the answer might be that all possible combinations of all the laws of nature exist in the inflationary multiverse. So then it's not surprising there are universes that permits things like us to exist, because every possible universe exists in the inflationary multiverse. And that's a well-supported theory. It's a theory, so this is not the same as saying there was a Big Bang, which we know. This is kind of, what's a theory? It's a guess, basically. But it is a theory that in its simplest form has made predictions that have subsequently been verified. And we could go on then as the so-called many worlds interpretation of quantum mechanics.
I mean, he says you have to be very careful with the language, but it's also the evolution. The Big Bang is also a theory, right? Theory is just like the highest valued word that you have in science, like the theory of evolution, theory of Big Bang. It doesn't mean that we don't know that it didn't happen, just that they formulated it like that. And he says we know this happened, but they always use the word theory beforehand, which is the highest regarded state in science. So I don't know if he is being careful enough with his words.
Hello guys, today we have the evolution of Giga.